application of the first order differential equation. So our group topic is about the growth population in Turkey from year 2003 to 2023.
For this project, we have chosen Turkey as the country to study in terms of population growth. We wanted to analyze how the population has changed over a period of time. The table below shows the data set includes the actual population of Turkey from the year of 2003 to 2023. The data we used was sourced from the World Bank, which is a reliable and widely used source for global statistic and development indicators.
To analyze the human population growth mathematically, we use the fundamental idea of Malthusine model, where it assumes that the rate at which the population of a state increases at a particular time is proportionate to the population of the state at that time. From the Malthusine model, dp by dt equals to kp, where k is the constant of proportionality. First, we solve the equation by separating the variable p and t. Then, we integrate both sides of the equation. We get p equals to e to the power of kt plus c. The general solution can be simplified to be p equals to ae to the power of kt, where plus minus e to the power of c equals to a. By substituting the initial value of t and p, we obtain the value of a. The general solution becomes equals to 67,831,730 e to the power of kt. We also find k constant by using t equals to 1 at 2004 and the number of population at that time. The particular solution now becomes pk equals to 67,831,730 e to the power of 0.01115 t.
Using the particular solution, we calculated the estimated population in Turkey from 2003 to 2023. All the values are recorded in Table 2. From the table, we can see that initially from 2003 to 2005, the values are nearly identical, but started from 2006 to 2010, the value from particular solution becomes generally higher. However, from 2011 to 2023, the value for actual population and particular solution started to deviate significantly, where the actual value become a lot higher than the estimated value. There are several reasons for the deviation, which will be discussed later on. Figure 1 shows the actual population of Turkey from 2003 to 2023. We can see in 2007, the population only increased slightly from 2006. Started from 2007 onward, the population increased steadily each year. Figure 2 shows the graph plotted based on the value using particular solution. We can see that the graph produces a straight line with constant increase in the population.
Next, by using the particular solution, we construct graph of exponential of population in Turkey from 2003 to 2023. The population in Turkey show a steady growth from 2003 to 2023. From the graph, we can see that the growth is positive, meaning the population grows over years in consistent and stable pattern.
Let's take a look at how we could have predicted Turkey's population trends before 2003 using the data we now have. We used t equal to -10 to represent 1993, where we managed to get approximately 61.7 millions. The actual value for 1993 is about 5.6 millions. The actual value is lower than the predicted value, and the reason will be discussed in the discussion part.
So, this is the prediction that we have calculated for 2025. We substitute value t equals to 22 to represent 2025, and we managed to get 86,689,267 for the number of population. Meanwhile, the actual population for 2025 is 87,685,426. Next, we use percentage error formula to differentiate the values from both actual and prediction data. The percentage difference is 1.14%. Why is the actual value higher than the predicted value? This will be further explained in the discussion part.
Now, let's discuss why there are differences in the actual value of population and the value we calculated using the particular solution. First of all, particular solution is made of assumption of constant birth rate, constant death rate, and no migration. Meanwhile, the actual population is influenced by several factors. For example, natural disaster, pandemic, immigration, or emigration. So, in our study, we found that Turkey has become one of the main hosts for the Syria refugees when Syria entered civil war started from 2011. Millions of Syria refugees entered Turkey, which increased the populations of Turkey started from 2011 to 2023. Therefore, the actual population in Turkey from 2011 to 2023 are generally higher than the estimated value using particular solution.
Let's move to the factors that has affected the population growth in the past decade in Turkey. One of the major drivers of population growth in Turkey before 2003 was high fertility rates, particularly in rural areas and eastern provinces. During this period, it was common for families to have 3 or more children. This was influenced by cultural traditions, lower access to family planning, and limited education for women. These high birth rates resulted in a strong natural increase in population, even as Turkey began transitioning into a more urban and industrial society. Although fertility rates began to decline slowly in the late 1990s series, they will be still high enough to keep the population growing at a steady pace. Throughout the 1990 series, Turkey faced several economic challenges that affected its population dynamics. The country experienced high inflation, unemployment, and a number of financial crises, including one in 1994. These conditions created uncertainty and stress for many families. As a result, some people may have delayed marriage or choosing to have fewer children due to financial pressure.
Factors that might affect Turkey's future population. First, immigration. Many people move to Turkey for job and safety. This helps the population to grow. Second, government support. Money and support from government help more people decide to have kids. Third, economy and jobs. A well economy and job opportunity help people more confident to start a family.
In conclusion, we successfully determined the population growth of Turkey from 2003 to 2023 by using Malthusian model, which was derived from the application of first-order differential equation. We found that the population of Turkey during the year is directly proportional with time. By using the formula, we were able to predict the population of Turkey in the past as well as in the future. The percentage error between the actual value and the calculated value is relatively small, which is less than 3%, which means this method is reliable.
For task 2, we were assigned to solve this problem using Simpson's rule. But first, let's learn about what is Simpson's rule. Simpson's rule is a numerical method used to approximate the value of a definite integral which is impossible to be solved using analytical integration. Simpson's rule uses the area under a parabola which is fitted through the function to be evaluated at 3 points in order to approximate the area under the graph of that function. Simpson's approximation formula in order to approximate the value of a definite integral from a to b is given by h over 3 multiplied by the sum of y naught, yn, the sum of y odd multiplied by 4, and the sum of y even multiplied by 2, where h can be calculated by dividing the difference between the upper limit and the lower limit by the number of subintervals n.
Assalamualaikum. For our task 2, we need to integrate this equation using Simpson rule, using x equals to 0 to x equals to 2.2, and we have 5 and 9 ordinates, and we have to give the final answer in 7 decimal places. So first, for our 5 ordinate, we have to calculate its h value first. So we use b minus a, and we divide it with 4, so we have 4 subinterval. We got this for our x value. So this will be our x value. Sorry. Okay, let's become the total again. So for our y value, we substitute the x value into the equation. Just do that real quick. Got this for our y value, and coefficient 1 for the first and the last one, 4 for odd number, and 2 for even number. Then this last column, we multiply their coefficient with their y value. We got this. And we will sum everything up. And we got this for our total. And for our h value, for our integration, we use 1 over 3. 1 over 3. We use 1 over 3, multiply with its h value, and its total. we got this for our final answer, and it's in 7 decimal places. And then for our 9 ordinate, we have to calculate its new h value since we have 8 subinterval. We got this for our H value, and then we put everything in each row, and the total will become 2.2 again. And we substitute each x value into the equation again, and we got this for each x value. We got this y value for each of them. And then coefficient, like I said earlier, 1 for the first and the last one, 4 for odd number, 2 for even number. And our coefficient for our last column, we multiply its coefficient with its y value, and we got this. And we use 1/3 times with h and the total value for the integration. And this will be our answer. Thank you.
Simpson rule estimates the area under the curve by drawing parabola. So for our 5 ordinate, we have 4 subinterval. So we split the area into 2 parabolic sections. And for our 9 ordinate, that's 8 subintervals. So we split the area to 4 parabola. So the curve is much smoother, and the parabola will better give you a more accurate area estimation.